Okay, so this is the electromagnetic spectrum. We're going to be filling this out. You're going to need multiple colors. This is what it's going to look like when you're done. So you need to have these colors for Roy G. Biv. So I'm going to show you how to fill this out real quick. Even if you pause the video before, just try to copy what I got. Please try to watch the video like this so you understand this. This is basically your notes for this section. So we call this the EMS portion of our unit because it stands for electromagnetic spectrum. Okay, and what that is basically a bunch of different types of energy that we observe in order to do regular day stuff and also to study space. So our most common ones that we use are going to be the first two right here, and they are radio waves and microwaves. And yes, microwaves like as in the device a microwave. However, it's actually used for multiple things. So to give you an idea, microwave radiation, that type of energy, is really strong that we actually use it for radar. And radio waves are used for a lot of different stuff. We use it for TV, we use it for cell phones. And not all cell phone technology is radio wave. For example, the cell phone towers would be closer to microwaves. That's why you constantly hear about them being dangerous and all of that stuff, because it is a little more high power, but radar's everywhere. I mean, if we were worried about that, then radar would have killed us off a long time ago. After that, it just gets stronger. Visible light, believe it or not, people see it as not being dangerous, but it's actually high power. It just doesn't cause any type of issues with us. However, it can be an issue with the fact that if you get, say, like a laser, right, which is something you can see and we put it in your eyes, it can damage your eyesight. So now it makes sense why. Because visible light's in the middle of this. It's actually stronger than even a microwave, and so that would make sense why it would make you go blind. So after microwave, we have what's called infrared. And those of you who are video gamers or like any type of military type things like weapons or strategies or history, know that infrared is basically IR. It's used in your TV remote. It's used in your night vision goggles or in video games, all those night vision scopes, all that stuff. And it's used at the supermarket doors. If you're a little kid and you've ever been to supermarket and said alakazam or whatever magical word you use, that's what technology uses for it. So when you break the light, the doors open, and that's exactly what they use is infrared, and that's why the light's red. Okay, an visible light's probably the easiest because obviously we use it to see, so our vision, and then basic photography, right? So photographs work in that energy is basically blasted onto a lens, or if you had an old school camera, into those little sheets of paper, and that's how you get that image. So photography. And then we just get to the dangerous ones. So after visible light are all of the dangerous ones. So the first type is ultraviolet. AKA UV, which is why you wear sunblock, because it's dangerous to your skin. So we use it, actually, it's what causes our sunburns. It is what's caused when you get a tan. And also when we do dental curing. So that blue light they use to cure a lot of the fillings and things like that, it's UV light. And then the last two are the most dangerous. The first of the two is X-rays, which everybody knows are dangerous. That's why we only get blasted with them for a few seconds versus a long period of time. And so the X-ray is used in luggage. It's used in medical screenings. Sorry, that should be an E. And last but not least is gamma. And if you've ever seen, if you're a Marvel fan, you like superheroes, this is how the Hulk got his powers, gamma. But in real life, it's actually used for some of the most powerful things. For example, PET imaging, which is like similar to the type of scans you get with CAT scans or MRIs. So you know they're very powerful rays that are being used. We use it for cosmic rays. We actually study space using gamma rays because that's what's in space currently. And any nuclear bomb, any nuclear power plant uses gamma rays. So now it makes sense why this stuff is dangerous, right? It's really high power stuff. And those are the 7 types of different basic energies in the EMS, in the electromagnetic spectrum. And so the way we study this is through waves. And so that's what I'm going to show you here, because waves are very easy but also very difficult, because it comes with a lot of different vocabulary people don't typically use. And then we'll focus on one particular one, and that's visible light, only because that's our most common one that we use every day. We'll do the colors, fill this in, and then you can just label everything so you can use it for all the worksheets you're going to do after this. So here we go. First, what you need to know is this is what a wave looks like, and I'm going to make it from long to short. So this is how it's going to look. We're going to start it up, and it's going to go pretty long. And every time we get further, it's going to look like it's getting closer and closer. Okay, so long to short. So this is actually your weak energy. Weak. And the reason it's weak is because in a wave, there's not a lot of energy that can be here in this wave. And obviously we can't see this, whether it be light or whatever, but this is how energy acts. It forms a wave, kind of like sound. And as soon as the wave actually gets compressed like this, where you have a lot of different crests and troughs, and you'll see what that is down here, then it gets really strong. So what you're seeing here is that all of this, radio, microwave, infrared, is your weak. And as we keep going down, it gets strong. So that makes sense why these are your most powerful and these are your weakest. Okay. So we have this big arrow here, and we're going to say what happened. So it increases, first off, in energy. That's why it's more dangerous. Second thing is the frequency. And frequency is the amount of times that you see these hills. So there's more hills here, more frequency. And also danger. The more crests and troughs there are, the more hills there are, the more dangerous that energy is going to be. Okay, and so now we're going to go down here and label those portions so you know what parts of the wave are. First off, this entire thing is called a wavelength. This is the length of the whole wave. And so that's what you're going to label over here. So this right here is your wave length. Okay, then we said that every time this happens, right, from here to here, that's your frequency. So we're going to label that real quick. So you're just going to go like this, and that is your frequency. I'm going to write it right below since I can't fit it on top. Okay, so we did wavelength, we did frequency. Right here, how tall that hill is, and really down here too, or anywhere for that matter, that is your what's called your amplitude. That kind of also decides how strong it is, or how much energy is present. The higher the hill it is, the more likely it is that it will have that energy for it. Even though, let's say here, right, it's happening very frequently, maybe the energy is not quite as strong. So if we were exposed to, say, a second of gamma, it might not kill you, might not cause any problems. Where if we were to make this hill much taller, then a second might actually cause a lot of damage. Okay, so that's amplitude. A trough is that bottom of the hill. It's like an upside down one. So that's your trough. And the top of the hill like this, that portion is called a crest. And that's all the fancy words for the different types of the wave. So this is just an anatomy of a wave. Okay. Now we're going to go back, because we need to look at one particular one, and that's your vision, visible light, and your vision, what you can see. So right here, if you've learned Roy G. Biv, you know that Roy G. Biv stands for red, orange, yellow, green, blue, indigo, and violet. So go ahead and label that. Okay, Now, these are important because in space, colors are very important to us. When we get light, we receive it through telescopes and all sorts of satellites as colors. And colors are very important because when we get too far, we actually get single colors. And so let's go ahead and color this section in so you see how the colors work. So first part is this is going to be your red. First two squares. And then you're going to do orange. And really, I think we have enough to do 3 squares. So let's go ahead and label that further. This is your red. And then orange. So every 3 squares, just go ahead and change the color. Doesn't have to be perfect, just has to look like it's there. And then yellow, then green. And then finally blue, indigo, and violet. So I don't really have a difference in colors, so I think I'm going to use this for the blue. And then I'm going to change the indigo, and see how we're down to only 4 squares? That's okay. We're going to change this to different colors. So I'm going to do this as your blue, see how, or your indigo, see how it's darker? So that's what I'm going to do. Obviously, if you don't, I have some color pencils, or if you have your own, you can ask around so you can lend you one. And then we've got our purple, your violet. Okay, so there's your colors. And that's your Roy G. Biv and how it's split up. Here's why it's important. On the STAR test, they want to know what happens when you get what's called a red shift or a blue shift. So if you see red through galaxies or stars, you know that it's moving away from you. So we call that red shift. And it just means that an object is moving away from the observer. So wherever you're looking through, it's moving away from you. On the other hand, if you see a color blue, it's called a blue shift because it means that an object is moving towards you. Wait a minute. Yeah. Now, we're going to double check these. Double check with your teacher because I believe it should be opposite. No, we're right. Red shift, the reason for that, so when we talked about the Big Bang Theory, the red shift is when an object is spreading apart, so it is getting further from you. And then blue shift is when it gets closer to you. So that's your EMS spectrum. That's everything labeled. Make sure you complete this and glue it in your journal. It is not something to turn in, but it is something you will use for other worksheets.